Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 2, Build Your Understanding, question number 28. The question is, one end of a spring of a stiffness K is attached to a nail O on an inclined plane and the other end to a small disk of mass M placed on the inclined plane. Inclination of the plane with the horizontal is alpha and coefficient of friction between the disk and the plane is slightly less than tan alpha. Find suitable expression for deformation delta R in the spring when the disk is in equilibrium at an angular position theta from the line of greatest slope. This is the line of greatest slope as shown in the figure. So acceleration due to gravity is to be taken as g. Let us solve this question. First important thing is we must find which direction the spring force should work. So in the question, it is given that coefficient of friction is less than tan alpha, means this tan alpha is just greater than angle of repose. If there was no spring, then the component of force of gravity along CD, that is the line of greatest slope, mg sin alpha, will be greater than the friction force which will oppose its motion. So definitely it will slide down. So to keep this disk on this plane in equilibrium, you must get a force that overcome the difference between the component of force mg sin alpha along CD and the friction force. So it means you must have a force, but in the question it is given that the spring is making an angle theta with the line of the greatest slope. Nail is over here. So means spring force must act outward in this direction so that one of the component will, in addition to the friction force, will counterbalance the component of force mg sin alpha along the CD. So this means that spring should be in compression. Now, which all forces are working on the disk when the spring is in compression, under compression? So one will be the force in this direction due to the spring, that is spring force. One is the component of force of gravity along CD, that is mg sin alpha. And one will be the friction force. And these three forces in total should be zero for keeping this disk in equilibrium. So this is the diagram which has been made when we are looking the disk perpendicular to the inclined plane. So your CD line has become vertical. mg sin alpha, which was acting here, we can show it like this, mg sin alpha. This theta angle along which the spring force is acting is FSP. And Fr, we have taken the friction force in random direction. If we make this diagram like this, so the force of gravity which is acting here, we can divide it into two components. One is in along the slope, which is this one, CD. One will be perpendicular to the slope, that is mg cos alpha. And the plane which is exerting a force perpendicular to it on the disk will be n. There is no motion or there is no acceleration in this direction, means the net force in this direction will be 0. So n will be your mg cos alpha. We have assumed the delta R compression in the spring. So K delta R will be the spring force. So what will be the friction force? Friction force will be mu into N. In the question it is given the coefficient of friction is just less than tan alpha. So we can approximate that it is equal to almost equal to tan alpha. So in place of mu we can replace it with tan alpha into normal reaction force. So friction force will be your mg sine alpha. For the disks to be in equilibrium, if we do the vector sum of all these three forces, it should be 0. For that to happen, these three forces should be able to constitute a triangle. So we are projecting this diagram over here. In this direction it is mg sine alpha, mg sine alpha. Parallel to this is your FSP, parallel to this is your spring force K delta R, and parallel to the friction force. Parallel to the friction means these two forces we have already drawn. So third force, that friction force must able to complete the triangle. So third force will definitely be in this direction from R to P. Now the PQ and PR is equal in magnitude. So this triangle will be an isosceles triangle. So this angle is theta. So this angle also has to be theta. So from here, from this triangle, this K delta R will be 2 times mg cos alpha sin alpha into cos theta. So delta R will be your 2 mg sin alpha cos theta by K. So this is the expression for which the question has been asked to determine. So this will be your answer. Hopefully you understood the concept. In case of any doubt, please do write in the comment box. I will clarify. And please subscribe the channel. Thank you.